All right, hope everybody's having a great weekend. The next problem I want to do is level 3, number 8, which says 1 minus sine squared divided by tangent squared. The first step, if you ever have tangent, secant, cosecant, cotangent, along with sine or cosine already in the function, as we already have sine, then we've got this tangent down here, is to rewrite tangent using sine and cosine. So if you remember those other or random or miscellaneous identities that I discussed in class, we said tangent is just also sine over cosine. So tangent squared is just sine squared over cosine squared. So therefore I can replace this tangent squared with sine squared divided by cosine squared. I therefore have 1 minus sine squared, that was already there, 1 minus sine squared, over big division sign, sine squared over cosine squared. I just replace tangent squared with sine squared over cosine squared. Then I'm going to keep it, change it, flip it, because it's fraction divided by fraction. So I get 1 minus, keep the top, sine squared theta over 1, times, change division to multiplication, and flip the bottom, which I did here. Sine squareds cancel out, and I'm left with 1 minus cosine squared. Then I say, okay, how can this be further simplified? Well, I know that the first Pythagorean identity says sine squared theta plus cosine squared theta equals 1. So perhaps there's a way to redo this one, in other words, rewrite this identity so that it looks like what I have left. And in fact, if I take this identity and subtract cosine squared theta on both sides, I'm left with sine squared theta equals 1 minus cosine squared theta. So now I'm in good shape because I see 1 minus cosine squared theta, which if you remember is what we had before, is equal to sine squared theta. So our answer therefore is just sine squared theta. Let me zoom out so you can get a whole panoramic view of what happened. Again, the ability to transform the identities and the ability to use the random identities is crucial for this problem, as well as for several others we'll be doing later this week. Hope you guys enjoyed the video, and that's it for problem 8, level 3.